You know, the whole room's seated. There's one desk left over there, and that one's for you. Go sit over there next to Michael. So I went over there and I sat in the desk next to Michael. You know, the desks that are like the cubby desks when you're a little kid, you sit in them. They've got like that pencil holder there in the middle. You can slide all your books inside, you know. Well, this fool was all the way in his whole body was inside of his desk. So I almost saw his lower half. So I had to knock on the desk when I sat next to him to say hi. I said, hello. He said, hello, what do you want? I said, I'm Chris. I'm your new table neighbor. I want to introduce myself. He said, I'm inventing something no one's ever seen before. I'll be out in a minute. I thought, what the heck is this kid doing? He's inventing something no one's ever seen before. And when he came out of the desk to shake my hand, I looked inside there, and this fool had taken every one of his crayons, all of them in the box, and had put them through the crayon sharpener, or the pencil sharpener, I'm sorry, and had a big pile of multicolored crayon shavings all piled up in here inside the desk. And I thought, oh no, I'm sitting next to the bad kid. This is not going to be good. I hadn't really done anything bad before that I could think of, but this is going to be trouble. And he said, what I'm going to do here is I'm going to shoot this glue I have into the pencil holder, and then I'm going to push the pencil shavings in, and we're going to turn it into a big crayon. And we're going to come back from gym, and that'll be dry, and we can make giant rainbows. I said, you got to be kidding me, because there was no rainbow crayon by Crayola yet. It didn't exist. Mike was right. He was inventing something no one had ever seen before. So he said, but I need your help. I said, I'll do anything. He said, can I trust you? I said, sure. And he said, all right, what I'm going to do is I'm going to squeeze the bottle, and it's going to make noise, and you're going to cough so the teacher won't hear it. And I thought, oh my God, I started to sweat. My hands got all clammy. And I said, all right. So he took the glue bottle and he started to squeeze it. And I would go, It worked. I couldn't believe it. I was shaking afterward. I was so scared of being bad. And Mike was right. We come back for gym class an hour later, and we pulled that thing out. We were making rainbows all over I thought Mike was the coolest kid I'd ever met in my entire life. He had a sister in 4th grade, apparently. She was much older than us. And she was teaching him things at home and from 4th grade. And then he was showing them to me before school as little lessons before 1st grade would start. So the next day when I come into class, I couldn't wait to sit next to Michael again. And Michael was already waiting for me. And he had a paper out, and on the paper, he had a square drawn. And it kind of like burst my bubble a little bit. I didn't want to tell him, let him down, that we'd already learned about shapes in kindergarten back in Del Rey, you know. And Mike said, well, slow down. Have you ever seen this before? And he drew a square on top of a square. And I said, big whoops, Mike, that's a square on top of a square. And he said, hold on, I'm not done yet. You know what he did next, right? What Michael did next blew my 1st grade brains all over the room. First, I didn't see it. He went like this with the first one. I was like, what is he doing? And then it started playing tricks on my brain. And then when he did this one, I went, oh man, I could see what he's doing. I couldn't believe it. This was magic to me that this was, because I'd seen 3D people, you know, drawings of things in 3D, but I didn't know how you do it. And he just showed me just connect these corners. And I thought, this is the coolest thing in the world. I said, Mike, can you do this with other shapes? He said, yeah, you could draw a triangle. You know, now mind you, you're not going to get a 3D pyramid from this, but you could put another triangle, offset it, and then connect the corners, right? Can we do that with a circle? Yep, we can make a circle, offset another circle, connect the sides. We got a cylinder. And what Mike showed me how to draw in 3D, right? Because my pictures didn't just have width, they had height, right? And they had depth. Pretty cool, 3D. And Mike was right, this was 3D, and I drew 3D things on my papers in all my classes ever since then, all the way through school, just like that. If I wanted to draw a 3D cereal box, I'd pretend there was a table, and I would draw the cereal box like a rectangle, and then I would, you know, Captain Crunch or something that I wasn't allowed to eat at home. And then what the secret was to go off to the corners and draw lines like this, right? Everybody's done that before. Have you done this on your paper? Did anybody do the cube like this? Yeah. And if you look at this mechanically, right, this face of the cereal box would be straight on. It's like it's got perfect width and perfect height. But then the other faces of the box travel away from us to one direction. They're all going off to this direction, and they're all going off on a 45-degree angle. All right. Okay. Well, what's wrong with that? Well, this is a type of drawing. It's called an oblique view, O-B-L-I-Q-U-E. And the oblique view is a view that gets used sometimes in industry, but pretty much it doesn't get used. And so if you're trying to show people two types of drawings that are used pervasively in industry, no matter what language you speak, for showing off a 3D product, we know we have the orthographic sketch on graph paper that shows the different views in 2 dimensions. We're going to learn that next week. But the type of 3D view you have to show for the form of it or the aesthetics is not the oblique view, right? The type of picture we're going to draw is called an isometric. And I still want to draw that cube, you know, I still want to work on my cube, and I'm still going to start with like a baseline, just something to draw upon. But in the isometric perspective, instead of the face being the first thing that's closest to us, this is a face on this box, right? This is the closest thing to us. And these other two faces are traveling away on a 45-degree angle to one direction. Finished cereal box in oblique view would look like this. And we're going to say, boo. We're never going to draw oblique view again. Boo, right? Instead of the face being the closest thing to us in isometric, the closest thing to us in this 3D picture is a corner or a vertice. Fancy word for corner, vertice. So the first two steps are baseline, perpendicular line, right? Baseline, perpendicular line. That's how I started off. So I have the corner as the closest thing to me. Next line I'm going to put in this picture is the big thing about isometric is that that not only is the corner the closest thing to me, but in this 3D picture, there is an angle that the faces will travel away, and that angle is a 30-degree angle. That's the standard, of 30-degree angle. But Chris, I don't have a protractor. No worries. I want you to estimate as we do this. You could have your isometric graph paper out right now, and it makes it very easy to just trace the lines on the angles. But we're going to try it just from here by estimating. So if I want to get a 30-degree angle, I'm going to just kind of estimate about halfway there would be a 45-degree angle, right? Halfway between each of these is a 45. So if I want to go to a 30-degree angle, I want to take this 45 degrees, I want to bring it down a little bit lower. And to me, that would be about a 30-degree angle there. I'll do the same thing off to the other side. Break that 45 into thirds, you could have 15, 15, 15. Think of it like that. All right. So now in this isometric view, the corner or the vertice is the closest thing to us. And then we start by drawing the other two faces that are going to go away from us on a 30-degree angle. That 30-degree angle is very important. All right. Remind me, what's the first step in an isometric sketch? What's the first line I'm going to draw here?
Baseline.
Baseline.
And perpendicular line.
And perpendicular line. And by the way, you'll notice I'm doing this with a marker. I don't normally draw with a marker just for the contrast I need it for the video. But when I'm drawing with a pencil, I'll draw two different ways. I'll hold my pencil where I plant my hand to the table and I'm moving my fingers like this, right? That's how a lot of us draw, right? I draw like that a lot too, but I also switch over to another way where I keep my hands, my fingers stiff, right? And what's moving is my wrist, my elbow, and my shoulder, and I'm kind of like a CNC machine. I move this stiff hand around and as I'm always moving it, but it's not always touching to the paper. There's just two different ways you could think of using the tool. You know what I mean? All right, baseline, perpendicular line. What's next?
30 degrees.
30 degrees. So not halfway, not a 45 degree, but 30 degrees. Next one, 30 degrees. All right. Now, every corner or vertice, just like this one's perpendicular, they're going to go perpendicular to the baseline too. Right. So I'm trying to estimate this into a perfectly symmetrical isometric cube. So if I did have a ruler, every single line in the isometric cube would be the same length. They'd all be the same length. Let me just finish this thought and we'll go on break. But I'm trying not to use the ruler or anything else. I just want to estimate. And so I'm going to try to put these parallel lines where I think they're going to be about the same height as this one. Let's start thinking about coming out like that. Yeah, somewhere around there. I'll draw these straight up and down, straight up and down. It can be tough to get those straight up and down because by tendency, we'll start to lean our line in toward this point, lean them in. So you want to watch you're not like trapezoiding in there. All right, and these lines aren't any taller. They just start higher up than the one in the middle, right? I know I'm really breaking this down into such minute details, but we're going to stop there. Actually, no, give me one more minute. One more minute. The next step in this picture, after a baseline, perpendicular line, 30, 30s, and the parallel lines. And then I'll take like a pencil or something else, a ruler, or just my fingers, and I'll kind of hold it on this 30-degree angle, and I'll start moving it away and stay parallel to it. So I can try to get this on a 30-degree angle as well. I'll try to get this to a 30-degree angle as well. And when I look at this, it's not a finished cube, but what I see is not a cube. Right now, I'm starting to see a book binding. Like that's the back of the book. Maybe these are the pages. You know, maybe somebody's back here. That alien that you're going to make the process drawings for next week, for week 8. This alien's reading a book right now about how to fly to the Earth in a UFO. They got smelly feet. But we don't want a book. We want an isometric cube. So when we get back from break at 6:12 or 6:17, we'll get back to the isometric. And if you're following along, but the isometric's too simple for you, I'm looking forward to seeing how your treasure chest with an open lid is going. Any questions before we hit the break? All right, cool. Great job so far tonight, everybody. We'll see you at 6:17.
Chris and Ken, just to reiterate, at 7:45, I have to leave. I'm sorry, 6:45, I have to leave.
Thanks, Jim.
Problem, Jim.
Kenny, can you hear me? Yeah.
Yep, can hear you. Got your papers big.
Cool. All right. So somebody refresh my memory. What are the first few steps that we learned so far to get the isometric view going?
Baseline.
Baseline.
Perpendicular.
Baseline. Perpendicular line.
30 degrees.
Okay, so not halfway, but a little lower. Not halfway, but a little lower. All right. Next,
Parallel.
Parallel lines.
parallel lines. Think of field goals.
Mm.
Straight up and down. Straight up and down. All right, next I could take a, just in case these two lines aren't the exact same height because I didn't measure them with a ruler, take a straight edge or something. I like to hold it on that line and stay parallel to it so I can keep that same 30-degree angle when I connect the tops here. All right. Now, when I'm doing this with students, I notice that they often have an urge to connect this corner to this corner, especially if they're not seeing something in 3D yet when they look at this. Like I said, well, you may see a book popping out or the corner of something, a building. Some students get the urge to do this because it just seems like a logical next step, to connect the corners. And if we did that, we're still an isometric perspective, but it's not a cube anymore. We've got like a piece of cheesecake or something here. Maybe it's cheesecake with like a strawberry filling inside. This is the crust.
That's so not fair. I'm so hungry right
You're
now.
so hungry.
Oh, sorry. Want me to draw some dog poop next so you're not hungry anymore?
Yes, please. Thank you.
Maybe it's the graham cracker crust of the back.
All right, that's
Graham
quite enough.
cracker. All right. We don't want cheese. Okay, let's get this cube right for the last time here. We'll get the cube proper. What's the rules again?
Baseline.
Perpendicular.
Baseline. Perpendicular line. Trying to make them all the same length, but estimating.
30 degrees.
Remember, not the 45-degree angle, but come even lower to 30 degrees. 30 degrees. And
Parallel
perpendicular
line.
line, parallel lines. Parallel lines. This is where I start using my hand different. Like I'm going to hold my hand stiff and just move my wrist, my elbow and my shoulder. And I start doing this. So I feel like I'm on the right angle and then I kind of hit it. I could have done this with the pencil or straight edge to try to keep those angles, one like this and then pull it out like that. But I'm trying to estimate it. So if you get it right, if these lines were to keep going, they would never intersect because they'd stay parallel to each other forever. And now I'm looking at this and I'm going, okay, I got an isometric perspective, but it seems like it's like this cube's a little like short, like it's been flattened out a little bit, like it's been compressed. It should be a little taller, I feel like. So what I'm going to do is I'm going to try another cube right next to it. And I'm going to try to make this cube even more symmetrical than the last one. And I might do 3, 4, 5 little ice cubes until I feel like I'm really starting to get it symmetrical, So I'd like you to work on that. I'd like you to draw a few cubes in a row until you feel like you've got it symmetrical all the way around. And once you feel like you've got one, like as close as you can get it that way, then you might want to pull out that isometric grid paper and actually measure one out and make it, 1 inch or 2 inches on every line and follow that isometric grid paper. Has anybody pulled the grid paper out yet to try it? Cool. Lauren, thanks for sharing your screen. If anybody else is willing to share what you're doing as you're drawing, that'd be cool. Oh, you do have the Cubert.
So in the spirit of
Whoa, Jim.
In the spirit of full disclosure, I teach the kids to do the cubes in like just a basic, like on a snow day, or if I have like too many A days in a row and I'm, have to catch B day up, like I usually, and then the extra credit is the isometric alphabet, which is really hard.
What is the isometric alphabet?
Like, how if you're going to draw your name, like in graffiti, you're kind of drawing your name in like 3D. If you Google like isometric alphabet, it's really hard. Especially if you have like a G, or like an M in your name.
Yeah.
But it's interesting because you could always start with the cube and then you could erase different components of the cube rather than working towards the letter. You could kind of, work.
Subtracting away from it.
Yeah,
Yeah,
subtract
that's-
away, so.
totally. I think of it the same way too, because when I see it you'll see in some of the sample ones, I put links in the agenda to like a Jamboard that had some previous student submissions for this assignment. And you'll see something huge, like Lauren's drawing. Like Lauren, before she had the treasure chest there, she had like a whole castle up. Oh, there's some isometric letters, like a castle like that. And it's like, how did you do that when you're looking at a whole big thing? It's the same way you eat an elephant, right? One piece at a time. And like, just to show you the power of this, if I, let's say I put my isometric grid paper out just so I could get a perfect isometric cube. But instead of making a cube, I made it more of a rectangular prism. So it was like, wider. So I've got this long box type shape here, and if I wanted to draw a 3D car, what I would do is I would pretend that this is the front corner of the car. It's the front corner, which means there's probably like some headlights here, and then I'm going to take this side shape of a car and I'm going to draw the side view of a car just on this one face. It's just going to be a little like if I were to draw it on a face like this, the side view of a car, just like that, but I'm going to have to skew it a little bit to work itself out in here. So anything that's going straight up and down will still be straight up and down in parallel, but other lines would have to follow. So let's see here. If I was going to draw the back of the car, this could be like the back. This is the trunk. And there's the top of the car, and then the hood, like that. That's the side kind of picture of a car. And then if I went from each piece of the car there and stayed on that 30-degree angle, and kept going off each corner of 30 degrees like this, you're not expected to be able to do this. I'm just showing you how I start to approach it if it's a big object. And then the same curve I have here for the side profile of the car, I have to mirror that curve out here. It all starts with that, starting at that one corner. How you doing with your cubes? I see a few people have a treasure chest starting to go there. When I'm doing a treasure chest, same with the cube, I might make it a little longer so it's a rectangular prism and not a cube. Just like the box I'm working in here. What I'm going to do is I'm going to put a little mark here at in the center between this corner and this corner and do the same thing back there. And then I'm going to estimate 2 straight lines that are going to just going to dot them for now, just so that they're, I want them to be straight up and down, parallel. I'll do another one here, straight up and down. That. Forget this stuff over here, that's nothing. And then I'm gonna, the same 30-degree angle I have on the rest of the object, I'm gonna use to connect the tops of these 2 lines. Then from one corner to the other corner, I'm gonna make this arch. Right now, look, now if I was to look at it from a head on, the arch would be a perfect arch, right? I mean, it would look symmetrical. But because it's on this angle, this arch is going to look skewed. So from here to here is a much bigger loop, much bigger half of an arch than that one there. Same thing here, from this dot to this dot, pass through the top of the arch. Yeah, I got more of a treasure chest here.
Looks like
You're still working on the cube. You're just working on the cube. We'll come back. I'm going to come back and look at your cubes in a second. And remember, if you're doing the cubes one at a time till you get a perfect one, you're estimating with everything. Once you get a really good one, then pull out your grid paper, your isometric grid paper, and a ruler, and actually measure out a perfect cube following on those lines. This looks like a treasure chest, but I have this thing where I look at something, I can always see it as something else. Maybe I did too many of those things where you look at the clouds as a kid and try to see images in them. But I'm always seeing things and other stuff. To me, this looks just like a mailbox too. If the mailbox was open, probably have to have a. There's the lid, there's the flag you stick up there. With the treasure chest, it's like opening the lid. Drawing lids can be tough, but if you open the lid just 180 degrees, it's pretty easy because then you could just continue to go back like this. The lid just is an extension, it keeps going back. And then I have the hoop down here. But drawing the lid cocked open like a quarter of the way, that might be more difficult.
Yeah, I don't think my lid's long enough.
Heh. Last night I was playing around. I was trying to draw like Viking ships just before I went to bed to burn off my brain energy. And I was thinking about how the ship might start in a box like this. That the ship might have like a boat shape, like an eye shape to it. And then I was thinking of it. I was thinking if there's people in there and they're kind of an isometric view too. Start drawing them like Minecraft people. Holding an oar. So as you set more things up with that baseline perpendicular line 30-30, you keep approaching it from there, your brain starts to pick pathways between neurons to see these things in 3D. And it'll get easier to draw that isometric cube without any supports, you know? How are we doing with the cubes? Maybe you want to share your cubes, how the cubes are going? And we're going to be here like this, just drawn straight through to the end of class. So if you have to excuse yourself to the bathroom or anything like that, you don't have to let us know. You just pop in and out. Before the end of class, I will go over the specific instructions for both the isometric and the process drawings so that you could start them, even though they're not due for 2 weeks.
Cube. Did it?
Who's got, oh, Ann, let me see.
Can you see?
Nice. Yep. And remember that just like 1 in 50 people, 1 in 50 people don't have that problem with spatial intelligence, so they can't picture something in their mind's eye. They might have more difficulty seeing something in 3D on paper. Go ahead, Catherine, what are you gonna say? You got yours?
I'm just gonna say, I have a son who is an artist and he does like with you with his Sharpie constantly. And he's like, go ahead, draw something. I doesn't, like you're saying, it doesn't come out anything at all like what it's supposed to. Well, I'm
That's
glad
it.
he has the artistic abilities. So
And without any artistic ability, if I have my ruler and a pencil, even without the graph paper, and I make sure that these are perpendicular, I know that's a 90-degree angle, right? And if I estimate, not a 45-degree angle, but I make sure to definitely come lower than a 45, stay on 30s. If I get to here, right, and I got a ruler, I can measure and go, okay, this line needs to be 1 inch. I make this one 1 inch and it's going to stop right there. And this one's going to be 1 inch, it's going to stop right there. And then these are going to be 1 inch. And I've got my ruler out, making sure I'm staying parallel. And I use my ruler to go from this line to this line. And use my ruler again to go from there to there. If I follow these techniques, right? And I've got the ruler on me and I can measure the lines, I can't go wrong. You know what I mean? I can get the cube. I get the cube. And if I keep reproducing the cube, if I practice it when I'm in a meeting or I'm talking to somebody on the phone, and I keep practicing that perspective, I'll get muscle memory in my hands for it, and my brain will keep forming pathways between neurons, and you'll get your spatial intelligence will get stronger.
I guess it's like anything. We had my students, we had a live with Steph Curry, and that's exactly the message that he said. He didn't have like the height or the speed or the anything. And he just said, I can keep on practicing, I can pursue my dreams because this is like what I really, really want to do. And he worked hard at it.
Is that a basketball player?
Yeah. He just wrote a children's book, and he did a live presenting it to them.
Oh, cool.
It was really cool.
Now, in isometric perspective for a cube, I want to nest a cylinder inside this cube, because we could all, without being in knowing what perspective we're in, we could draw up a little oval anywhere and go, okay, let's put straight lines down off the sides, just like these parallel lines, and let's make this cylinder. But in order to know if my cylinder is actually an isometric perspective, we'd have to nest it inside of a cube just to see what this ellipse, how big should this ellipse be? Should it be a real thin ellipse, or should it be a big ellipse? You know what ellipses are, right? Somebody you kiss on the internet? That's a joke. Ellipse. Anyway, you're right, honey. Nobody laughed at that one. My wife's not in the room. So what I'm going to do is go back into my cube and put a little halfway mark on each of these corners or vertices. And I'm going to make an arc between each one of these points, which will turn, this arc here, and then this arc, from there to there, from there to there. Now I know if this is isometric cube, that I've positioned the ellipse or the oval in the isometric perspective within it. And the sides of the oval will go straight up and down, just like the sides of the cube, straight up and down. But if we're making a cylinder, got the oval, got the straight up and down. Does this look right to end the cylinder at the bottom like this with a straight line? That was a can of soup? No, it wouldn't work out. In a front view of a can of soup, sure, the front view of a can of soup on an orthographic drawing, the edge that Ken's going to do with us, the front view of a can of soup will actually be a perfect rectangle. You'd only see the front. You wouldn't even know it's round looking at the front view of a can of soup, right? If it was just dead ahead of you in the front view, you wouldn't be able to see the top or the bottom. So it would just look like a rectangle. But in this view here, the same curve we have at the top, we've got to mirror that curve at the bottom. And so what I'd like you to do is move past the cube now, or the treasure chest. And I'd like you to use the same mechanics to try to set yourself up an isometric cylinder, maybe inside of one of your cubes. And then once you've got the sense for how big that ellipse should be or how wide, then I'd like you to draw a can of soup in isometric perspective. Just like I'm starting off here. Can of soup. Got the same curve at the bottom that I have up here at the top. And on the can of soup, I'm going to curve the label too. And then I'm going to draw pictures. This is just for funsies. I'm going to draw a picture and see if you can guess from my picture what my favorite soup is. I've got two of them. So I'll do my first one here while you practice yours. I'll let you know when I'm done. See if you can guess mine. You work on your can of soup. Now, if the can of soup is very simple for you and you're thinking, oh, it's too easy, Chris, give me something harder. Maybe you can make a 3-tiered cake that has candles positioned around the cake on the different layers. Or you could try, what could we do? It's cylinder. Or you could try a Lego piece with like with a couple studs on top of it, you know? And when I say studs, I'm not talking about the guys in this room. I'm talking about those little bumps on top of the Lego. Thanks for laughing at that one, Catherine.
Hello again on another Monday morning. I have come to realize in recent years that there are times when there's only one word in which I can express my faith.
Anybody guess my favorite soup?
Pea soup.
Split pea? The pea?
That's ham.
It's quite sufficient.
Put them together?
Ham and split pea.
Yeah, you got it. Split pea and ham. That's good. My college kids, our undergrads, they guessed clam and flounder.
There's no other word.
Clam and come on, I'm not that bad of a drawer. I'm gonna draw my second favorite soup, and then we're gonna ask to see some of yours.
Guys, have a good week.
Thank you, Jim.
Jim.
You too.
No other word. There's no other word.
Yes, Robert.
Are you done?
No.
Mom, did you touch the cupcakes inside the refrigerator?
Nope. Oh, I'm
Right.
sorry.
Who's that, Robert? Or
It is Robert.
hey, wait, Rob. Did you get the job?
Did you get the job, Robert?
There's my
This is rather involved. I had to utilize an additional engineering drawing technique called the magnified view to get my point across here. In addition to isometric orthographic, there's a couple of little extra bonus little things. You learned about pictorial verbiage last week where you can use lines to start to suggest action in a picture, right? I'm using the magnified view now, where if there's something I want to show in my picture, it's too small to make out the details. I just draw a circle around it, and then I pull off to the side. I scale up that circle real big and then draw the same object inside there. And so what I'm trying to show here is that this is me holding what is a needle and thread, right? And in this picture, you see this magnified, it's the name tag I'm wearing there. It says, "Hi, my name is me." And I'm fixing a shirt I had that had a rip in it.
Miso?
Yay, you got it. Miso soup. It's the best I could come up with.
Okay. All right.
Andrew's laughing. My husband's laughing.
Who's got one that they can share? It's all about just trying to get that isometric perspective on the can, but for funsies, do you have anybody have a label you could share with us? Soup.
I don't have the label, but I did the 3-tier cake.
Nice job. Nice job.
I find the cylinders to be easier. Is that weird?
No, it's not weird because there's those sharp corners to get in the perspective. It's just this, and it can look like
Struggling.
it'll look 3D, and no matter what you do, if you try to
Yeah.
whip one out, but is it in that perspective? You're going to know whether or not, depending on how open or closed the ellipse is at the top.
Definitely struggling with the cubes outside the paper.
Yeah. In those cubes, if you have a ruler on you, Jamie.
Yeah.
So when you do your baseline and you do your perpendicular line,
Uh-huh.
whatever length you make this perpendicular line, let's say you make that an inch, right?
Mhm.
Then for every other line you're going to make now, use the ruler, but actually measure it out, right? To an inch.
Right.
And even though we think we're going lower than a 45, sometimes we got to put a 45 right through the middle there so that we could definitely go a third lower.
Yeah, I
So we
find when I have
know-
to go the left side, since I'm a righty, the left side's harder.
Oh, I do the same thing. I can never
Yeah.
make things symmetrical.
It's
I always
never
have to draw half
symmetrical.
of it. I always got to draw half of it, fold the paper over, go like this with my fingertip over,
Yeah.
and transfer the image over. But yes, I suffer from the same thing. But if we start mechanically approaching it that way, where everything's the same length, then it's almost impossible not to get the cube right if we got the 30-degree angle. And so if we try with the training wheels or with the grid paper, and we mechanically set a bunch of them up properly on there, then when we switch over to regular paper without the 30-degree angle, it should be easier to estimate it. And for many people, this might be the longest you ever spent drawing before. If you never had an art class, I don't know what would lead you to go sit and draw for 2 straight hours. Just like projects, you have to build up stamina for it, just from doing a bunch in a row. Oh, Lauren, you got a lava lamp there.
Yeah. I don't know. I was trying to think about other things. I think a lava lamp is pretty easy. I don't know.
Yeah, the cylinders can be easier, right?
Just thinking about like the different ellipses that are in it and like sizes.
Yeah. I'm just gonna map out one of these Legos with like the 6 studs on it. You know, and there is 1-point perspective and 2-point perspective that you definitely learn about in an Art 1 course. But isometric is typically not taught in art class.
Why not? Why not?
I don't know exactly, but in my experience, it's just not one of the go-to perspectives that you get taught.
I think
They'll
it's
teach
More
more
in the lines of
technical.
technical.
Jinx Kenny.
Yeah.
But when it
I think
comes to
that's
if
more
you're
technical rules where the perspectives are more like illusions.
Yeah, you got like vanishing points and that other kind of stuff, more artistically speaking, right?
Where when you look at like an isometric, you should be like, if it's drawn, if it's not just sketched, like you should be able to take your architecture scale and like measure that, like this is maybe like 3 inches and this one is also 3 inches.
So you'll notice what I'm going to do here for a Lego with 6 studs on it is I'm going to take the cube and I'm going to grid out 6 equal spots on top of it. And then put a little center point in there around which I want my ovals or ellipses to go. And I want to try to make sure that that ellipse fills out almost the profile of the inside of that square. And then from here, I'm going to extrude them or lift them up. So I'll put a straight lines. And it's kind of neat because the one starts to block the one behind it, And then matching oval up top. Again, you can say I hold my, when I'm doing my ellipses, I hold my hand stiff and just move my elbow and my shoulder.
Chris, I find it interesting that I primarily do things with my right hand and I'm drawing like it from the other angle than you are. You see that?
Yeah. So in the isometric sketching assignments, it says to pick an object, take a regular piece of paper, and maybe draft a picture first, like map it out real fast with pencil somewhere, so that you kind of get the lay of the land and how much space it's going to take up and what it's going to look like. And then once you have a good sense of it, then on a fresh piece of paper, put it down there solid with pencil. And the isometric is about form and aesthetic. So once the 3D picture is done, then we could color it in. And this would show off what it would look like in real life, floating there in space, or you could set it against the background, or maybe it's 2 or 3 objects nestled together in your picture. It doesn't have to be a single item. But we don't want you to do is 2 things I don't want you to do. One is I don't want you to pick a cinder block because there's no detail to it, right? It wouldn't be. And the other thing is I don't want you to make a can of soda because it's just a cylinder and you don't have to like work out any of these 30-degree angles. You know what I mean? So you want to try to find an object that challenges you, right? That could be something it would take you the whole hour to complete it. But things that are just straight cylinders, we want to avoid. We want to find things that have right angles in them and corners and stuff like that. Just for a quick reference, if you are in an art class and you're learning to draw perspective drawing, they go back to what starts like an oblique view. And if I was doing a a cereal box, I would start with the face drawn square close to me, but then the sides aren't going to move away on 45-degree angles or 30. They're actually all going to converge on a single point in space, whatever angle that is to reach that point. And so all these edges go away to that point. And then you go back to the depth of your object, and just like these go straight across, this would go straight across, just like this goes straight up and down, this would go straight up and down. That's 1 point perspective. We're not doing that. If you were to elongate something though, you notice a building in 1 point perspective would really start to disappear as it moves away from you. You know what I mean? Moving away. When I look at this, I already start seeing like a truck or something. A big 18-wheeler, you know, barreling down the cab they sleep in up top. That's for aerodynamics. Anyway, that's 1 point. 2 point perspective would say, well, back to having a vertex as the closest thing to you. The corners are the closest thing. And somewhere on some horizon line, there's 2 different vanishing points on the same horizon line. And so vertices stay up and down, but then from one corner to the other, you're going toward one dot or the other in your pictures. I'm just mapping this out to show you how it's done. We're not trying to do these for this class though. So here's a bunch of blocks where the points are moving to the 2 different dots I have out there. You can see how these 3 cubes are now vanishing to 2 vanishing points in a 2 point perspective. So we're not doing either one of those. Back to isometric. And now for the next 10 minutes, I'm gonna go fast through these. It's just to expose you to it. So you could go back, watch the video and slow it down if you want to practice some of these. But they're not required. But I'm gonna show you how to do a sphere, a waving banner, a classic lobster claw flame for like flames, and maybe some like spray or like smoke. All right, this is gonna be fast. It's just to expose you to it. Try along with us if you'd like on your paper, and you could always put these techniques to use in one of the sketching and drawing assignments if they're helpful. All right, for funsies, with a sphere, for a sphere, I'm going to always try to get a perfect circle to start with, and then somewhere in my circle I'm going to draw a little oval, probably up there at the top like that. You know, and I could use shading to show that that some things are closer to me and other things are further away. You know, I would darken the back of the ball, but I'd leave it real open and white in the front. And that would be a way to use shading to tell the ball's getting closer. But if I'm not using shading, the only way I can create the depth perception is with lines. And so if that's the center of the dot and this line goes around like this, the next oval will come a little bit lower. And you just watch, see what I'm doing here. I'm trying to make like almost make it look like a yarmulke there now, a little yarmulke. And then I keep coming down, and this next one's going to go down even greater depth. You know, that was a little gap from there to there. That's a big gap. Now we're going to go much bigger gap with the bottom one. And then a close gap down there. And I have to pass through that dot and make an X, not a regular X, more like the Xbox X that kind of curves up and down and then curves up and down. This is the kind of X I'm about to make here. I'm going to pretend I'm behind the ball, and I'm coming up and over through that dot and around. I do the same thing over here with the X. Come up from the back, through the dot, and around. And now this is the biggest area here, right? This is going to feel like it's the closest to me. And then the other areas keep getting smaller as you go away. That's how we can use line to create the perception of a 3D sphere. So let's try to organize a circle. Get the little oval up top, slightly larger one, real big one. And I pass through the center up here with an X that comes from the back and loops around. And another one that comes up from the back and loops around. You don't have to feel confident with these ones. This is just to try, just to see it. You can get the isometric cube and get that perspective straight. That's the goal for tonight. Maybe I want to turn this into an igloo, right? Maybe I need a igloo, so maybe I need like a 30-degree angles coming off here somewhere. I'll put like a hoop here. Come back on a 30, come back on a 30. There's my igloo. I could change the position of this little circle too. So it's more like there. Sometimes I'll look at this like it's a face. Think where the eyes and the nose going to go and the mouth. And maybe they've got spikes that come out of their head here, evenly spaced around. Halloween Hellraiser mask.